Capacitors can be grouped in two ways: series grouping and parallel grouping. Let's understand how to calculate the total capacitance in both configurations. In a series grouping, capacitors are connected end to end. Imagine three capacitors, labeled C1, C2, and C3, connected to a battery. When the circuit is completed, charge flows to the left plate of the first capacitor, creating a positive charge. Due to induction, a negative charge forms on the right plate, and the same process continues across all capacitors. Since the potential difference gets divided across the capacitors, we use this formula to find the total capacitance. 1 divided by total capacitance equals 1 by C1 plus 1 by C2 plus 1 by C3. This means the total capacitance in a series circuit is always less than the smallest individual capacitor. Now, in a parallel grouping, all left terminals of the capacitors are connected to one side of the battery, and all right terminals are connected to the other side. Here, the potential difference remains the same for each capacitor, but the charge is divided among them. The total charge is the sum of the individual charges. Using this, the formula for total capacitance in a parallel circuit is total capacitance equals C1 plus C2 plus C3. This tells us that in a parallel circuit, the total capacitance is simply the sum of all the capacitances